19 minutes. That is all it took. Not hours, not days, not the sustained attrition campaign of a weeks-long ground battle with its grinding advances and its costly exchanges and its gradual erosion of fighting capacity. 19 minutes. From the moment the first wave of Iranian autonomous kamikaze drones dropped below radar coverage across a 40-kilometer front to the moment the last attack run completed and the wreckage assessment began. And what had been one of the most formidable armored formations in the Middle East ceased to exist as a functional fighting force. 112 Merkava Mark IV tanks, not damaged, not temporarily disabled, destroyed, burning across 3 separate staging areas in columns of fire that were visible from 40 kilometers away, their ammunition cooking off in secondary explosions, their fuel cells rupturing, their crews, the ones who survived the initial impacts, emerging from hatches into darkness filled with the sound of incoming rotors and the smell of everything they had trained to fight from, turned to ash around them. This was not an ambush in the traditional sense. There was no opposing armored force, no anti-tank missile teams dug into hillside positions, no guided rocket artillery registering rounds on grid coordinates. There was no enemy soldier within direct engagement range of a single Israeli tank when the killing started. There was only the swarm. 800 autonomous kamikaze drones, pre-programmed with the GPS coordinates of IDF armored assembly areas that Iranian intelligence had spent months mapping through satellite reconnaissance, signals intercepts, and human intelligence assets embedded in the logistical supply chain. 800 machines that made their own decisions, identified their own targets, confirmed their own engagement geometry, initiated their own terminal attack sequences, without a single human hand guiding them in real time. 800 weapons, each costing between $15,000 and $25,000 to manufacture, that in 19 minutes destroyed more than $400 million worth of the most survivable main battle tanks Israel has ever built. The economics of that exchange alone should stop every defense planner on Earth cold. But the economics are only the beginning of what happened tonight. Because what Iran deployed against the IDF's armored division was not simply a large number of drones. It was a fully operational, combat-validated autonomous weapons system, a system that identifies targets through machine vision, coordinates its attack geometry through distributed mesh networking among the drones themselves, times its waves to exploit the specific reloading windows and saturation limits of active protection systems, and executes the entire operation below the threshold at which conventional early warning architecture generates an actionable alert. The Merkava Mark IV was engineered to be the most survivable main battle tank in the world. Its designers spent decades studying every anti-armor threat in the operational environment and building defenses specifically against each one. Trophy, Israel's active protection system, was specifically designed and specifically deployed to defeat exactly the kind of top attack threat that drone strikes represent. Israel had watched the 2020 Nagorno-Karabakh War, watched Armenian armor die in columns to Azerbaijani TB2 Bayraktar drones, watched the playbook unfold frame by frame in publicly available footage, and spent billions upgrading its armored fleet specifically to survive the scenario that played out tonight. Trophy failed. Not at the margins, not in isolated cases, at scale, systematically, comprehensively. Tonight, in 19 minutes, Iran did not just destroy an armored brigade. Iran invalidated an entire doctrine of ground warfare that the Israeli military has built its operational confidence on for half a century. And in Tel Aviv, when the phones started ringing in the war cabinet with the early damage assessments coming in, the silence on the other end of those calls was the silence of a military establishment confronting, in real time, the fact that the world it had planned and procured and trained for no longer exists. We are going to tell you exactly what happened, all of it, how the swarm was built, how it was deployed, why Trophy failed, why American intelligence did not see it coming, what it means for armored warfare globally, and what it means for the strategic balance in a region where the rules just changed in 19 minutes. Stay with us. Every answer is here. There is a pattern to how military revolutions are recognized. They happen in the field first, in a single engagement, on a specific piece of ground, against a force that was considered capable and prepared. And then the analytical community spends years arguing about whether what happened represents a genuine paradigm shift or a tactical anomaly that better tactics and better equipment will resolve. The tank survived the shaped charge. It survived the guided anti-tank missile. It survived the early drone threats. After every generation of anti-armor innovation, the defenders adapted, the doctrine evolved, the armor got harder, the active protection got faster, and the tank remained the decisive instrument of ground combat, because nothing else combined firepower, protection, and mobility in a package that could seize and hold terrain. What happened tonight is not another round in that iterative exchange. What happened tonight is categorically different. Different in the autonomy of the weapons, different in the economics of the exchange, different in the scale at which the capability can be produced and sustained. And the defense establishments that fail to recognize that categorical difference, because they are emotionally and institutionally invested in the continued relevance of the platforms they have spent decades building, will not get a second chance to update their assessment. This matters right now, in this moment, for reasons that extend far beyond the burning tanks in the Negev and the Jezreel Valley. In Washington, the Pentagon's armored warfare specialists are looking at tonight's engagement data and asking questions about every heavy armor formation the United States Army plans to operate in every theater where drone-capable adversaries might be encountered. In Moscow, engineers who have been operating in the drone warfare space with far less sophistication than Iran has now demonstrated are recalibrating what the next generation of their own autonomous weapons programs needs to achieve. In Beijing, defense planners who have watched Iran's progression from the Shahed 136 to tonight's autonomous swarm are taking notes on a capability roadmap they intend to replicate at a scale that makes Iran's achievement look like a proof of concept. The deterrence architecture of the entire Middle East changed tonight. Every ground force in the region, Jordanian, Saudi, Egyptian, Turkish, is recalculating the survivability of its armored formations against an adversary that has now demonstrated it can field 800 autonomous kill vehicles in a single coordinated strike. The Israeli military, whose entire doctrine of rapid, decisive, offensive ground action depends on armored formations that can advance under fire and absorb attrition without losing combat effectiveness, is recalculating whether that doctrine is executable at all against an adversary with this capability. This is not a tactical setback. This is a doctrinal reckoning. Before we go any deeper, this is exactly what this channel was built for. We do not repeat what the wire services filed this morning. We do not summarize the official statements. We go into the systems, the doctrine, the engineering, the strategic architecture, and we trace the full consequence chain from the battlefield to the boardroom, to the war college, to the alliance headquarters where the real recalibration is happening right now. If that depth is what brought you here, hit like, subscribe, and turn on notifications, because this story is not finished. What happened tonight is a chapter, not a conclusion, and you need to be here for every development as it unfolds. Leave your analysis in the comments. Tell us what you think this means for the future of armored warfare, for Israeli doctrine, for American security guarantees in the region. The best analysis in this space happens in this community, and tonight, this community has a lot to process. Now, 4 questions, because that is where every serious examination of tonight's events has to begin. 4 questions. The ones that every IDF commander, every Pentagon armored warfare specialist, and every defense ministry official watching tonight's footage is asking. The ones that almost no mainstream outlet has the technical depth to answer. First, how did 800 Iranian drones cross into Israeli operational airspace and reach their targets without triggering the layered early warning architecture that the IDF and the United States have jointly maintained and continuously upgraded at enormous cost? And what does that failure tell us about the fundamental limits of radar-based air defense against low observable terrain-masking drone swarms? Second, the Merkava Mark IV was specifically engineered with top attack protection in mind, and Trophy was specifically deployed to defeat the drone threat vector that was demonstrated in Azerbaijan in 2020. Israel watched that war, studied that footage, and spent billions on the upgrade. Tonight, Trophy failed at scale. Was this a saturation failure? A sensor threshold failure? Or has Iran specifically reverse-engineered Trophy's engagement envelope and designed its terminal attack geometry to stay outside it? Third, 800 drones require months of logistical preparation, assembly, programming, target coordinate loading, dispersed launch positioning, coordinated communication architecture. The signature of that preparation, spread across weeks of activity across multiple sites, should have been detectable. Where was American and Israeli intelligence during those months of preparation? And what does the answer tell us about the fundamental mismatch between intelligence architecture, optimized for fixed-site ballistic missile programs, and the distributed, dispersed, operationally opaque signature of autonomous drone swarm preparation? And fourth, Iran used 800 drones tonight. Its current production capacity is estimated at between 800 and 1,200 units per month across all variants. If tonight was not Iran's maximum effort, and it demonstrably was not, what does the follow-on look like? What happens when the next swarm targets power generation infrastructure, desalination plants, port facilities? What happens when the target profile shifts from military formations to the civilian infrastructure that makes modern societies function? 4 questions, 4 answers that the official narrative will not provide. Let us go into each one. To understand what happened to the IDF's armored division tonight, you need to understand the specific tactical problem that autonomous drone swarms create for armored vehicles. A problem that the global defense establishment has understood theoretically for years, watched play out empirically in multiple conflict theaters, and still has not solved. The Merkava Mark IV is an extraordinary machine by the standards of conventional armored warfare. It weighs 65 tons. Its composite armor array combines steel, ceramics, and reactive elements in a configuration designed to defeat shaped charge warheads and kinetic penetrators from any frontal or lateral angle. Its Trophy active protection system uses a phased array radar to detect incoming anti-tank threats, calculates their intercept geometry in milliseconds, and fires a shotgun pattern of metal fragments to destroy them before they reach the vehicle. In Lebanon in 2006 against Hezbollah Cornet teams. In Gaza across multiple campaign cycles against rocket-propelled grenades and anti-tank guided missiles. The combination of Merkava armor and Trophy protection proved operationally formidable against every threat it was designed to face. The autonomous drone swarm operates in a completely different physics. Trophy was designed to detect, track, and engage projectiles approaching at high velocity from lateral vectors, missiles fired from hillside positions, rockets launched from urban structures, anti-tank rounds from hardened fighting positions. The engagement geometry is fundamentally horizontal, or close to it. The threat approaches from the side. Radar detects it on a trajectory that intersects the vehicle's armor. Countermeasure fires. Threat is destroyed or deflected. The system works exactly as designed. The kamikaze drone descends from directly above at a terminal dive angle between 70 and 90 degrees. It approaches at relatively low velocity, slow enough that Trophy's radar threshold, calibrated for high-velocity ballistic threats, does not reliably generate an engagement solution. It targets the engine deck and the turret ring, precisely the areas where even the Merkava's extraordinary armor is thinnest, because the physics of vehicle mobility imposes absolute limits on how much vertical protection can be added before the weight makes the vehicle immobile under its own power. This geometry is not a discovery. It is not an insight that Iranian engineers stumbled upon. It is a well-documented vulnerability that has been present in tank design since the introduction of top-attack warheads in the 1970s. What changed is not the vulnerability. What changed is the delivery system that exploits it, and the scale at which that delivery system can be deployed simultaneously against multiple targets without a human operator bottlenecking the kill rate. The operation tonight unfolded in 3 precisely timed waves, each designed to exploit the specific gap that the previous wave created. The first wave, approximately 250 drones, struck the northernmost armored assembly area where 2 armored battalions had been staging for potential offensive operations. These drones flew nap-of-the-earth profiles through the Jordan Valley corridor, hugging terrain at altitudes below 20 meters to remain inside the ground clutter shadow of Israeli radar coverage. They arrived simultaneously across a 2-kilometer front, attacking from multiple azimuth angles to prevent tank commanders from orienting their vehicles to present maximum frontal armor to the threat. The targeting logic within each drone had been preloaded with infrared and optical reference imagery of Merkava tanks, fuel trucks, and ammunition carriers, acquired through months of satellite collection and processed through machine vision algorithms trained specifically on IDF armored vehicle signatures. When each drone's sensor suite matched a target image above a confidence threshold, the terminal attack sequence initiated autonomously. No human confirmation, no communication uplink to a ground controller, no command delay. The second wave, 300 drones, struck the central staging area 40 seconds after the first wave impacts began. That 40-second gap was not arbitrary. It was calculated with precision. 40 seconds is approximately the window during which trophy systems that survived the first wave would be processing the initial engagement, assessing residual threats, and attempting to reconstitute their engagement picture after the saturation event of the first strike. The second wave arrived in that reconstitution window, hitting before trophy could reset, before crew members who had survived initial impacts could button hatches, before the command net could transmit coherent situation reports that would allow any surviving force to maneuver out of the kill zone. The third wave, 250 drones, completed the operational design by targeting the logistical support architecture: fuel trucks, ammunition carriers, recovery vehicles, mobile command posts, field maintenance teams. The components that give an armored formation its operational endurance, its ability to sustain movement, sustain firepower, sustain the command coordination that converts individual vehicles into a coherent fighting force. An armored brigade without fuel and ammunition is not a fighting force. It is a collection of extraordinarily expensive and completely immobile metal. Iran's operational planners understood this. They sequenced the third wave to arrive precisely when surviving tank crews would be orienting toward the logistics area for support, and found only fire. The damage assessment figures speak with a clarity that no analytical commentary can improve. Within 19 minutes of the first wave's arrival, an IDF armored division that had existed as a functional combat-ready formation ceased to exist as one. The materiel losses were devastating. The personnel losses were severe. But the deepest loss was something harder to count and impossible to replace on any short timeline. The loss was certainty. The operational confidence that Israeli armored formations could advance against Iranian-equipped adversaries, absorb anti-armor fires, leverage trophy protection to survive the threats they would encounter, and achieve the decisive ground outcomes that Israeli doctrine has been built around for 5 decades. That certainty is gone, and the commanders in Tel Aviv know it is gone, and Iran knows they know it. The story of how Iran developed the autonomous swarm capability deployed tonight is one of the most consequential technological achievements of the 21st century, and one of the most comprehensively misunderstood by the Western analytical community that was responsible for tracking it. Start with the foundation. The Shahed 136, Iran's first widely deployed loitering munition, became internationally prominent through its large-scale use in the Ukraine conflict, where Iranian-supplied variants provided Russian forces with a mass-producible precision strike capability against Ukrainian infrastructure. Its design is deliberately simple: a delta-wing airframe, a 2-stroke engine derived from commercial equipment, GPS navigation with a basic terminal guidance system. Against undefended targets or lightly defended air environments, it is devastatingly effective. Against sophisticated layered air defense with adequate early warning, it is manageable to intercept. Iran knew this. Iran designed it this way, deliberately, not because the Shahed 136 was the destination, but because it was the manufacturing foundation from which something fundamentally more capable could be built. Every production run, every operational deployment, every engagement provided data that fed the next iteration, and the next iteration after that, and the one after that. The progression from the Shahed 136 to the autonomous swarm systems deployed tonight took approximately 5 years and involved 3 discrete technological advances, each building on the last, each solving a specific operational limitation of what came before. The first advance was miniaturization and signature reduction. The drones in tonight's strike are significantly smaller than the Shahed 136, lower radar cross-section, reduced thermal signature, quieter acoustic profile. Iranian aerospace engineers achieved this miniaturization through domestic development of components that Western sanctions had placed beyond Iran's import access. The propulsion system is an Iranian-designed turbofan derivative running on a kerosene air mixture that produces substantially lower acoustic signature than the Shahed's two-stroke engine. The airframe is constructed from domestically produced carbon fiber composite materials. The electronics package is built around Iranian-manufactured integrated circuits that Western analysts had consistently assessed as beyond Iran's domestic fabrication capability. Those assessments were wrong. They were wrong for the same reason they are consistently wrong about Iranian technical capability. They were grounded in a framework that could not accommodate the possibility of sophisticated indigenous development outside the Western technology ecosystem. The second advance was autonomous target recognition. The machine vision system aboard tonight's drones was trained on imagery datasets assembled over years of Iranian intelligence collection, satellite imagery, commercially available photographs, technical drawings acquired through intelligence channels, and in some cases, direct analysis of captured or commercially procured Israeli military equipment. The resulting neural network can distinguish a Merkava Mark IV from a civilian truck under thermal imaging conditions with high confidence, even when the vehicle is partially obscured by camouflage netting, terrain features, or electronic countermeasures. Training a neural network of this capability requires substantial computing infrastructure. How Iran acquired sufficient computational resources under comprehensive technology sanctions is a question that the Western intelligence community is urgently examining. The answer almost certainly involves a combination of domestically developed hardware, cloud computing resources accessed through intermediary jurisdictions, and technical assistance from partners whose identities are not diplomatically convenient to name openly, but whose initials are not difficult to infer. The third advance, and the most operationally revolutionary, was swarm coordination. Individual autonomous drones, however sophisticated, can be defeated by a determined adversary with sufficient early warning and interceptor capacity. One drone, one intercept. The kill capacity needed to stop a swarm is bounded by the number of interceptors available and the rate at which they can be employed. Against 100 drones, that math might still favor the defender. Against 800 drones arriving simultaneously from multiple vectors, time to exploit specific gaps in the defender's reload cycle, the math becomes catastrophic for the defense. The swarm coordination architecture that Iran deployed tonight does not require a real-time communications link to a human operator. It operates on a distributed mesh network among the drones themselves, each drone broadcasting its position, status, and target assignment to its neighbors, which update their own flight paths and target selections accordingly. The mesh network uses frequency-hopping spread-spectrum communications that are extremely difficult to jam because no single frequency carries enough of the coordination data to matter if it is denied. Severing the link to individual nodes does not disable the swarm. It redistributes the coordination function among the remaining nodes. The testing and refinement history of this technology is as important as the technology itself. Iran did not deploy an untested system tonight against one of the world's most capable armored forces. It deployed a mature, operationally validated system that had been iteratively refined through live testing in 3 separate conflict theaters. Houthi operations in Yemen provided years of operational data on drone navigation, endurance, and terminal guidance against Saudi and UAE air defense systems. Real combat conditions against real defenders with real consequences for every failure, producing real lessons that fed real design improvements. Hezbollah drone operations in Lebanon provided specific data on Israeli radar and electronic warfare response profiles, helping Iranian engineers understand the exact detection thresholds and reaction timelines they needed to operate beneath. Operations in Syria and Iraq provided additional data points on how Western-derived intelligence and surveillance systems track and respond to drone launch preparation activity. Each theater was a laboratory. Each failure was an investment in the next version. Tonight's swarm is the product of that investment. refined across years of genuine operational feedback, into a system that is not just theoretically capable of doing what it did tonight, but empirically validated at doing exactly this. And the production scale that sustains the strategic threat deserves its own separate emphasis. 800 drones in a single operation represents a significant fraction of a monthly production run, not the entirety of Iran's strategic reserve. Iranian drone production facilities, dispersed across dozens of sites, multiple hardened underground installations, deliberately oversized relative to immediate operational requirements, and specifically architected to survive Israeli air interdiction campaigns, are currently estimated to be producing between 800 and 1,200 units per month across all variants. The production rate exceeds the operational consumption rate even at high operational tempo. Iran can sustain operations of tonight's scale repeatedly without depleting inventory. The arsenal is not a finite stock waiting to be exhausted. It is a continuously replenished operational capability, and the production infrastructure that sustains it is substantially underground. You cannot exhaust it by conventional attrition, and you cannot destroy the production base without accepting an escalation threshold that Washington has not yet been willing to cross. The failure of Israeli defenses tonight, the failure of Trophy, the failure of early warning, the failure of command coordination to generate an effective response within the engagement window, is not a failure that can be explained by a single intelligence miss or a single technical shortcoming. It is the failure of a set of layered assumptions, each of which was reasonable in isolation, and each of which compounded the others into a catastrophic collective result. The Trophy saturation assumption. Trophy was designed, evaluated, and procured against a threat model built around engagements involving one, two, or at most several simultaneous incoming threats against a single vehicle. The engineering team that designed it had to make choices about radar sensitivity, engagement prioritization logic, and countermeasure reload architecture. The choices they made were entirely reasonable given the threat model: an anti-tank guided missile fired by a Hezbollah crew, a rocket-propelled grenade launched from an urban structure, a Cornet round fired from a concealed position. Against 8 drones arriving simultaneously from multiple azimuth angles at a single vehicle, Trophy's engagement prioritization logic faces a computational triage problem it was not designed to solve. Which target takes priority? The one arriving fastest? The one arriving from the angle with the least armor protection? The one whose terminal geometry gives the system the most reaction time? The system must choose instantly, and accept that it cannot engage all 8 simultaneously with the single countermeasure charge available in each reload cycle. Iran's operational planners appear to have specifically modeled Trophy's engagement prioritization architecture and designed the attack geometry to present the maximum number of simultaneous targeting dilemmas. This is not improvisation. This is reverse engineering, the same disciplined analytical process that Iran applied to the GPS receiver architecture after the RQ-170 capture, applied this time to the active protection system of the tank it intended to destroy. The radar detection assumption. Israeli early warning radar infrastructure is optimized for ballistic missile detection, for large aircraft, for high-altitude reconnaissance assets. The low-altitude, low-velocity, terrain masking profile of tonight's drones was specifically designed to exploit the gap between the bottom of that coverage and the ground. Nap of the Earth flight at 20 meters altitude through a terrain corridor like the Jordan Valley does not produce a reliable radar return against a system looking for ballistic missiles at 60 kilometers altitude. The detection architecture had a floor, and the swarm flew below it. The communications saturation assumption. When the first wave hit, the IDF command net experienced something that had not been planned for. Simultaneous emergency traffic from dozens of vehicle crews across 3 separate staging areas, all attempting to report, request support, and receive guidance at the same moment. Communication systems that function adequately in conventional engagements, where emergencies develop sequentially and command channels can process them in order, broke down under the simultaneous load of a synchronized multi-point attack. Abort orders, evasion instructions, and rally coordinates that might have preserved some combat capacity could not be transmitted to surviving crews who might still have been able to respond. The deepest failure, doctrinal blindness. Israel watched the 2020 Nagorno-Karabakh War. Every senior IDF officer knows what TB2 Bayraktars did to Armenian T-72 formations. Israel specifically studied that conflict and specifically invested in trophy enhancements as a result. What Israel appears to have failed to internalize was the critical difference between TB2 operations in Azerbaijan, where human pilots controlling individual drones created a human bandwidth bottleneck that limited the attack rate, and the fully autonomous swarm architecture that Iran deployed tonight. In Azerbaijan, the drones were terrifying and highly effective, but each drone required a human operator watching a video feed and making a targeting decision. One operator, one drone, one target. The kill rate was bounded by human decision speed, multiplied by the number of available operators. Tonight, there were no operators in the loop. The drones made their own decisions at machine speed. The kill rate was bounded only by the number of drones in the swarm and the time required to complete terminal attack geometry, and neither of those constraints imposed any meaningful limit on the operational outcome. The IDF upgraded its active protection systems to survive the Azerbaijan model. Iran built the next model. The doctrine that informed Israel's billion-dollar upgrade was already obsolete by the time the upgrade was complete. That is not a failure of execution. That is a failure of conceptual imagination. The failure to anticipate not just the current threat, but the next iteration of the current threat, built by an adversary that is specifically engineering each new capability to defeat the defense developed against the previous one. Pull back from the battlefield. Pull back from the technical details of trophy saturation and mesh network coordination and nap of the Earth flight profiles. Pull back to the level of global strategic architecture and ask the question that no official statement will answer directly. What does tonight mean? For Israel, the country's entire military doctrine, the doctrine of rapid, decisive offensive action, the doctrine of short wars ended quickly on terms that restore deterrence, the doctrine built on the assumption that armored formations can advance under fire and deliver the ground effects that air power alone cannot produce, has lost its principal instrument of execution. You cannot conduct a rapid, decisive ground offensive with armored formations that are catastrophically vulnerable to an autonomous swarm that costs 1/10,000th as much per kill as the vehicle it destroys. The math does not work. The doctrine does not survive the math. Israel faces a strategic choice it has not faced before in its modern military history. How to generate deterrence and execute military objectives against a ground-capable adversary, when the ground capability that has historically been the final guarantor of military outcomes is operationally compromised. Air power alone cannot hold ground. Special operations forces cannot substitute for armored formations in large-scale ground maneuver, and the rebuild cycle for tank-heavy armored formations capable of operating against autonomous swarm threats, new countermeasures, new doctrine, new training, new equipment integration, is measured in years, not months. For the United States, the Pentagon is tonight asking every question about its own armored formations that Israeli commanders are asking about theirs. The M1A2 Abrams is one of the world's most capable main battle tanks. Its active protection system, an American trophy variant developed through U.S.-Israel cooperation, faces exactly the same saturation vulnerabilities that Israeli trophy systems demonstrated tonight. Every American armored formation that might be committed in support of an ally or in defense of a theater, in Europe against Russian pressure, in the Indo-Pacific against Chinese action, operates inside the same conceptual vulnerability that Iran just exploited in live combat conditions. The procurement implications are immediate and expensive. Directed energy weapons capable of engaging multiple simultaneous aerial threats are the most promising counter-swarm technology, but they are power-hungry, require substantial generator infrastructure, impose weight and mobility penalties, and are not yet operationally deployed at the scale required to protect armored formations across a contested front. Developing, producing, and fielding them at operational scale is a multi-year, multi-billion-dollar program that does not generate usable capability on the timeline the current operational situation demands. For Russia and China, Both are watching tonight's engagement with the specific attention of powers that have invested heavily in autonomous weapons programs and are now observing a real-world validation of the operational concept those programs are designed to realize. Russia's drone warfare capability, developed through operational experience in Ukraine and augmented by the technical exchange relationship with Iran, will incorporate tonight's lessons into the next generation of its autonomous strike architecture. Russia's military-industrial complex has the production capacity to build drone swarms at scale that makes Iran's output look like a pilot program. The operational proof of concept that Iran provided tonight accelerates Russian confidence in the concept and the Russian political will to invest in its further development. China's position is more consequential still. Beijing's autonomous weapons programs are more technologically sophisticated than Iran's. Its production capacity is orders of magnitude larger. Its AI development ecosystem, its semiconductor manufacturing base, and its defense civil fusion approach to technology development give China the ability to build autonomous swarm capabilities at a scale that is qualitatively different from anything Iran has demonstrated. What Iran proved tonight at the tactical level, against a single armored formation on a 40-kilometer front, China could replicate at the operational and strategic level against carrier strike groups, against Taiwanese armored forces, against any conventional military formation that depends on human-controlled engagement timelines and predictable threat geometry. For the global arms market and alliance relationships, the Gulf states, Saudi Arabia, UAE, Kuwait, have spent hundreds of billions of dollars on American armored vehicles and the active protection systems designed to make them survivable. Tonight, every defense ministry in the region is reassessing whether what they paid for delivers what was promised in the threat environment they actually face. The conversations that will happen in Riyadh and Abu Dhabi in the coming days between defense ministers and their American counterparts will be quiet, professional, and very uncomfortable. And the nations of the global south that have been told for decades that their security depends on purchasing Western military technology at prices that create permanent financial dependency and strategic obligations are watching a sanctioned, isolated nation produce a capability that defeated that technology's most celebrated embodiment in 19 minutes. The message does not require translation. The mathematics speak directly. Israel's options in the aftermath of tonight's engagement are real. None of them are adequate to the scale of the problem, and every one of them carries costs that the governments involved are not yet ready to publicly acknowledge. The technological remediation option, directed energy systems, laser and high-powered microwave weapons capable of engaging multiple simultaneous aerial targets, represent the most technically credible counter-swarm answer. Israel's Rafael and Elbit systems have been developing directed energy capabilities for years, and the Iron Beam laser system has been publicly demonstrated in testing environments. Emergency acceleration of Iron Beam deployment to surviving armored formations is almost certainly the highest priority Israeli defense program as of tonight. But Iron Beam has limitations that are not solvable on short timelines. It requires a substantial power generation infrastructure that imposes its own logistical burden on a deployed force. Its effective range against small, fast-moving targets in contested electromagnetic environments is bounded, and deploying it at the density required to protect armored formations across a contested operational front requires a production scale that does not yet exist. Partial deployment is possible. Full solution is not available on the timeline the operational situation imposes. The kinetic suppression option. Direct strikes on Iranian drone production facilities and launch infrastructure. This is the option that addresses the root capability rather than its symptoms, and it carries the highest escalation risk of any available choice. Iranian production facilities are dispersed, hardened, and substantially underground. Neutralizing them comprehensively requires sustained strategic bombing of a scale that constitutes a major military campaign against Iranian territory. An action that crosses escalation thresholds that neither Washington nor Tel Aviv has currently chosen to accept, and that carries retaliation risks across multiple domains simultaneously. Striking the launch infrastructure, the dispersed mobile teams that positioned and launched tonight's swarm, requires intelligence about location and timing that demonstrably was not available in advance of tonight's operation and may not be consistently available for follow-on operations. The doctrinal adaptation option. Restructuring Israeli ground warfare around formations that are less vulnerable to swarm attack, more dispersed deployments, greater integration of counter-drone systems at every echelon, development of new tactical concepts for armored movement in swarm-contested environments. This is the right long-term answer. It is a years-long program of conceptual redesign, equipment development, and force retraining that does not generate usable operational capability in the near term. The American intervention option. Direct American military action against Iranian drone infrastructure, using USAF strategic assets, naval aviation, or ground-launched precision fires to destroy the production, storage, and launch architecture that enables swarm operations. This is the option that Washington has the military capability to execute and the political reluctance to accept, for reasons that are as much domestic as strategic. American munitions inventories remain at levels that complicate sustained high-intensity campaigning. American public tolerance for direct military engagement with Iran is a political variable that the current administration is carefully managing. And the risk of Iranian responses against Gulf energy infrastructure, against American bases in the region, against Hormuz transit, creates a consequence calculus that argues for restraint over intervention. What Iran has constructed, deliberately and patiently across 2 decades of sanctioned isolation, is a strategic situation in which every retaliatory option available to its adversaries carries costs that exceed the benefits at the threshold of acceptable risk. That is not an accident. That is the design. Build a capability that is distributed enough to survive air attack. Make the production infrastructure underground and redundant. Make the economics asymmetric enough that the defender cannot afford to match it interceptor for interceptor. And deploy it in a way that demonstrates its full operational scope in a single engagement, so that the deterrent effect of the capability is established in the minds of adversary planners before the next use. The deterrent effect has been established. Every armored force in the Middle East now operates in the shadow of what happened tonight. And that shadow does not dissipate because better air defense is procured or better doctrine is written. It persists because the capability that created it persists, underground, distributed, and producing 800 new units every month. Wars change when weapons cross thresholds they were never supposed to cross. The tank appeared in 1916 on the Somme and crossed the threshold between defender advantage and attacker mobility. The aircraft carrier appeared in the Pacific and crossed the threshold between surface fleet range and power projection. The precision-guided munition appeared in the Gulf and crossed the threshold between industrial-era area bombing and surgical strike. Each crossing rewrote doctrine, rewrote strategy, rewrote the institutional assumptions of every military that had been built to operate in the world before the crossing. Tonight, a threshold was crossed. Not by a superpower with $1 trillion defense budget and decades of accumulated technological advantage. By a nation that has been told repeatedly, officially, and with great institutional confidence, that it lacked the capability for exactly what it just demonstrated. A nation that built its answer not in years of open collaboration with Western research institutions, but in the disciplined, patient, operationally tested secrecy of an engineering culture that had no choice but to solve its own problems, and found in the necessity of that constraint a strategic innovation that the unconstrained could not anticipate. 800 drones, 19 minutes, 112 Merkava tanks. The arithmetic is simple, the consequences are not. The consequences propagate through every armored doctrine in every military on Earth. They propagate through every active protection program, every counter-drone procurement, every wargame scenario that defense establishments have been running against swarm threats in classified exercise environments, and will now be running with a very different sense of urgency. They propagate through the alliance relationships that depend on American military technology being sufficiently dominant to deter adversaries that are now demonstrably less deterred than the alliance agreements assumed. They propagate through the procurement contracts, the strategic plans, the deterrence calculations, and the political arrangements that were all structured around a world that did not know this was possible at operational scale tonight. and now cannot unknow it. The Merkava that Israel built was the best answer its engineers could give to the questions of armored warfare as they understood them. It was not enough, not because Israeli engineering failed, but because the question changed before the answer was ready. History is the story of questions changing faster than institutions can follow. The militaries that survive the change are not the ones that build the best answers to yesterday's questions. They are the ones that recognize, quickly enough to matter, when the question itself has been replaced. 3 questions for you to carry into the discussion below. Has the age of the main battle tank as a decisive instrument of ground combat come to an end? Or is this another iteration in the long cycle of threat and adaptation that armored warfare has survived before? If Iran can produce and sustain this capability under comprehensive sanctions, what does the next version of this capability look like from a nation with China's industrial base, China's AI development ecosystem, and China's strategic patience? And most fundamentally, what does tonight tell us about the future of deterrence in a world where a $25,000 machine can destroy a $5 million one in autonomous operation, without a human in the kill chain on either end of the equation? Leave your best thinking below. Share this with someone who needs to understand what actually changed tonight, because the official briefings are not going to tell them. Subscribe. Stay sharp. Stay informed. The next development in this story is already in motion, and when it arrives, you need to be here.